In this interactive guide, you'll learn how to detect and respond to modern attacks with unified security information and event management, or SIM, and extended detection and response, or XDR, capabilities. You'll see how a unified SIM and XDR experience makes it possible to automate threat investigations, helps close critical gaps, and empowers a rapid response when threats are detected. To navigate this interactive guide, follow the prompts on the screen or use your forward and back arrows. Azure Sentinel is a cloud-native SIM solution that delivers intelligent security analytics across your entire organization. It collects data at cloud scale across all users, devices, applications, and infrastructure, on-premises and in multiple clouds. And it enables security operations teams to make threat detection, investigation, and response more efficient with AI and automation. To get started, select Incidents. This is the Azure Sentinel Incidents page, which provides an overview of all incidents detected in your environment. In this example, you can see 3 incidents which were created by Microsoft 365 Defender, Azure Sentinel, and Azure Defender, respectively. Let's investigate the high-severity alert titled Potential Malware Uploaded to a Storage Blob Container. To do so, select the incident title. To see if there is any immediate action that needs to be taken to protect the organization, we can investigate this alert in Azure Defender. Azure Defender helps protect your Azure and hybrid cloud workloads with built-in XDR capabilities. Customized threat intelligence and prioritized alerts allow you to focus on what matters the most. Let's explore the entities related to this alert. Expand the Azure Resource entity. Here, we can see the resource ID of the affected storage account. Here, we can view details on the potential malware file that was detected in the storage account. We can also see the name of the malware that was detected in the scanned file. Azure Defender was able to detect this file because it used a known bad hash. Now let's see how we can use Azure Defender to take action. This screen provides recommended steps that an administrator can take to mitigate this threat. Let's view one of the recommendations. This recommendation includes both quick fix and manual remediation options. We can review the quick fix logic before selecting the quick fix option. This script disallows public access to the Azure storage account. Let's use the quick fix option to resolve the issue. The remediation was successful. We can similarly review the other 2 security recommendations to better protect the compromised storage account going forward. For now, let's return to Azure Sentinel. Let's perform a deeper investigation into the impact this attack had. This is the investigation graph for the incident. The investigation graph helps you understand the scope and identify the root cause of a potential security threat by correlating relevant data with any involved entity. A blob storage alert is triggered when Azure Defender detects malware with a known bad hash being uploaded to Azure Blob Storage. Let's take a closer look at the graph. In the investigation graph, we can see that the alert contains entities such as the file name, the blob storage account affected, the file hash, and the attacker's IP address. We can see this is the same malicious file we observed earlier in Azure Defender. Azure Sentinel allows you to create custom detection rules. In this case, a custom rule that was previously created uses the malicious IP to check blob storage logs for additional files that may have been uploaded, and then extracts the file hashes for those files. You can see that the attacker uploaded not only a malicious file, but also 2 additional files. Open the linked malicious storage artifacts alert details. We can use a playbook to share these additional hashes as custom threat intelligence indicators. When executed, this playbook will share the new file hashes with Microsoft 365 Defender, enabling Defender to detect the presence of these hashes on machines within our network. Let's run the playbook. Now, let's return to the Incidents page to figure out how an attacker gained access to our environment. We can see that Microsoft 365 Defender has created an endpoint incident for initial access and credential access. This might tell us how the actor gained a foothold in our network. Let's take ownership of this incident since we'll be investigating it. Changes we make to an incident in Azure Sentinel are automatically synchronized with Microsoft 365 Defender and vice versa. For example, the change to ownership we just made will be synchronized between the two products, allowing improved incident management. While Azure Sentinel provides a great breadth of information about attacks on the environment, Microsoft 365 Defender enables deep analysis of endpoint exploitation. This Microsoft 365 Defender page provides a summary of the incident, including associated alerts and categories, the scope, evidence, and other important information about the incident. Before continuing our investigation, let's quickly confirm that the change to the incident has been synchronized. The incident has been assigned to our account. Three alerts were triggered when an Office application ran suspicious PowerShell commands, which might be when the initial access into our network occurred. Let's drill into the alert details. The alert story shows that Microsoft Word was used to open an attached file, which probably arrived in a spear phishing email. We can see that after opening the file, a number of suspicious PowerShell commands were run, and eventually command.exe spawned x.exe. Scroll down to review the alert story. Several reconnaissance commands were executed. Also, a PowerShell execution occurred that called out to the same IP address we saw implicated in our blob storage attack. Tasks were then scheduled to run hourly using the binary servicehost.exe. Let's close this browser tab and return to Azure Sentinel to investigate whether servicehost.exe is associated with any other incidents in our network. The investigation graph shows the full scope of the intrusion using first-party and third-party alerts and log sources. You can see the impacted machine and user account in the center, as well as the Microsoft 365 Defender alert to the right. One of the file hashes we saw for the blob storage alert earlier has been associated with the Microsoft 365 Defender incident. This links the on-premises Microsoft 365 Defender alerts to the Azure Defender blob storage alert. The service host file used for persistence on-prem was uploaded to blob storage by the attacker. The custom detection rule we saw earlier allowed indicator sharing with Microsoft 365 Defender, making this connection possible. Furthermore, another analyst investigated Azure activity logs for additional malicious IP activity and bookmarked the hunting query, which is linked to the malicious IP address. The query results show that the attacker used the user account to view blob storage keys. The attacker then used the keys to upload files to our blob storage, likely for use in future campaigns. Azure Sentinel custom detection rules and custom indicator sharing made it possible to link the on-premises incident with the cloud incident. If we wanted to, we could further enrich the attacker IP address details by bringing third-party logs and alerts into Azure Sentinel. For example, we could bring in Cisco ASA logs using the Cisco ASA connector, which would also allow us to determine if the attacker IP has been accessing our on-prem network. Now that we've investigated this incident, let's see what actions were taken in response to the attack. This incident triggered an automation rule playbook, which blocked the compromised account and then added a comment confirming that the account was blocked. The comment supports rich text and links to the automation rule. From the automation page, select the rule to see its logic. When an incident is created, the rule checks if any analytic files have tactics containing credential access, and if the incident provider was Microsoft 365 Defender. If so, the playbook will execute to block the Azure Active Directory user. This playbook automation blocked the compromised account in Azure Active Directory before our investigation even started, removing the attacker's access and allowing us time to investigate the scope of the attack. You've just learned how to detect and respond to modern attacks with unified security information and event management, or SIEM, and extended detection and response, or XDR, capabilities. Thanks for watching. This interactive guide is now complete. For more information about this topic, check out these online resources.